green technology arise because natural resources are declining and pollution has increased due to the abundant use of non-renewable source. Green product and creative are by definition and environmentally friendly, energy efficiency, recycling, etc. So green technology, sometimes people mention that clean technology, yeah, and environmentally friendly. This is the term of green technology. Yeah, green technology should reduce or minimize the degradation of natural environment. It should have zero or minimum emission of greenhouse gas. It should be safe to use and should promote a healthy environment for all the forms of life, including humans, bird, animal, etc. It should help in the conservation of energy as well as natural resources such as solar, water, wind, etc. It should promote the use of renewable resources. Component of green technologies. This is a component of green technologies. Protect the environment. Yeah, this is the first component. That this technology will protect the environment. And green technology less polluting. Yeah, this technology will decrease the pollution, and green technology use all resources in the more sustainable manners. Yeah. Yeah. Sometimes the people also mention that green technology is zero waste technology. Yeah. Clean technology. Sometimes clean technology. And the other components of green technology recycle more of the waste and product. Yeah. Yeah. Green technology include technologies that in general produce low or no waste, increase resource efficiency and energy efficiency, help to treat pollution. The green technology policy to provide direction and motivation to continuously enjoy good quality and healthy environment should be based on 4 pillars. So this is 4 pillars of green technology. 1, energy. 2, first pillar is energy. Second pillar is environment. The third pillar is economy, and fourth pillars is social. In economy pillars, seek to attain energy independence and promote efficient utilization. And the second pillar on environment, conserve and minimize the impact on the environment. And the third pillar on economy, enhance the national economic development through the use of technology. And social pillar green technology will improve the quality of life for all. Yeah, this is a policy tool to improve national diffusion capacity for green technology, support for higher learning and research and development, stimulate FDIs and domestic investment, develop environmentally friendly legislature, stimulate greater usage of renewable and energy-saving technologies, support SMEs in adapting green technologies, and promote among general public the usage of green technology. The development of infrastructure for green technology transfer, green technology education campaign to promote the green technology readiness. So we have to make a campaign how to promote green technology application and how to promote the green technology readiness for people. Green technology innovation fairs, conferences and workshops, and business incubators, research and development centers part with appropriate access to ICT and industry. So this is the need for the infrastructure development for green technology transfer. The stakeholder involved in the green technology is governments, private sector businesses, national development institution, media, public groups, civil society groups, individual consumer. Okay, green technology is a broad term and a field of new innovative way to make environmental friendly change in daily life. It is created and used in a way that conserve natural resources and the environment. The use of green technology is supposed to reduce the amount of waste and pollution that we mentioned before that are created during production or end consumption. It is also referred to as environmental technology and clean technology. Also, it is difficult to precisely define the areas that are covered by green technology. It can safely be said that green technology is the development and application of product, equipment, and system used to conserve the natural environment and resources, which minimize and reduces the negative impact of human activity. This technology should meet the needs of society in ways that can continue indefinitely into the future without damaging or depleting natural resources. This is the branches of green technology: green information technology, green building, green nanotechnology, green transportation, green chemistry, and green energy. The last two branch now is related to biorefinery, green chemistry and green energy related to biorefinery. Yeah, the importance of green technology is from the author from Malaysia. It is essential that create model of green building. Okay. The strength and advantage of green technology. The world has a fixed amount of natural resources, some of which have already been depleted or ruined. For example, household green technology offers us the best hope to counteract the effect of climate change and pollution. It does not emit less harmful substances into the environment. For instance, the solar cell which directly convert energy from natural light into electrical energy via the process of photovoltaic. This the next advantage is rejuvenating ecosystem. Green or green technology is also being used to breathe life into ecosystem that have sustained a lot of damage to the human involvement. And green technology has become popular as consumer of technology are becoming more environmentally friendly. Okay, we talk about the biorefinery. Among all renewable energy sources, biomass is the largest, most diverse, and most readily available resource that offers the opportunity to generate a wide range of new polymer and bioproducts. Yeah, we can see the approach, different approach of biorefinery system. Yeah, unlike conventional, yeah, oil refinery process, biorefinery is a facility that integrate biomass conservation, conversion processes and equipment to produce feed, food, fuel, value-added chemicals and energy, power and heat from biomass. We can see the figure by we can see the biorefinery system come from lignocellulosic biomass in the left side, energy crops, other biomass resources, and the system will produce biogas, bioethanol, biohydrogen, biobutanol as energy product, and chemicals and feed product for animal. Okay, this is the sustainable processing of biomass. Yeah. Okay. The concept of green biorefinery. Second, green biorefineries are multi-product systems which utilize green biomass as an abundant and versatile raw material for the manufacturers of industrial products. The concept is currently in an advanced stage of development in several European countries, especially Germany, Denmark, Switzerland, and Netherlands. The basic idea of this concept is to utilize the whole green biomass like grass, alfalfa, and various other sources to generate a variety of products that are either valuable products themselves or form the basis for future production line. In green biorefinery, the careful wet or green fractionation technology is used as a first step or primary refinery to isolate the green biomass substances in their natural form. Okay, we can see the concept, the system of the green biorefinery. Yeah. First chain come from field, grassland, harvest and chop, and wet green fractionation by press, and we can get press cake and press juice. After that, we can produce energy and chemicals and food or feed. Yeah, some problem affecting its industrial utilization and recommendation are described as follows. This is the problem: feedstock selection and evaluation. The second problem is the development of technologies for production of biofuel and bioproduct from the press cake. And third problem, development of industrial green biorefinery technologies. And the fourth, evaluation of the overall sustainability of process technologies. Yeah. To cover this problem is on sustainability. LCA, yeah, can be used as a tool to develop sustainable biorefineries. This is the most powerful tool, yeah, to assess the sustainability of biorefinery. Yeah, life cycle assessments. Yeah, can we see from this figure to 27.1? Yeah, from natural resources we can extract of raw material and design and production, packaging, distribution, use and maintenance, and disposal and recovery. So in life cycle assessment, we can assess the impact of the input of energy, water, and chemical during life cycle of the product. This is a life cycle production in life cycle assessment. This is methodology of life cycle assessment. We have to set goal and scope definition, and after that we make life cycle inventory data, and from the data we can assess the impact, yeah, of input and output, and from the result of the impact assessment is we can interpret in interpretation. This is the standard of LCA methodology based on ISO 14004. Okay, this is an illustrative example of how we use the LCA methodology. Yeah, the two biorefinery strategies which have been chosen for comparing using LCA. We have to select which one is better. The one strategy, bioethanol production from the forest residue feedstock using thermochemical process. Mixed alcohol are produced as co-product. And the second one, bioethanol production from corn stopper feedstock through a biochemical process. Electricity is produced as a co-product. We can compare the two types of conversion technology, which biofuel are produced and biochemical and thermochemical technology. We can compare which one is better based on the LCA analysis. Okay, this is the flowchart how thermochemical process using forest residue. In the box, we can see the growing, harvesting, transport, and production. From the production, we can get wastewater treatment and sludge and catalyst, and we can use ethanol. We can produce ethanol. The below biochemical process using corn stopper feedstock. Growing, harvesting, transportation, production, we get ethanol, electricity, emission to the air, impact. This is a system boundary for LCA analysis. Yeah. From analysis, we can get the data and we can interpret how the impact. Yeah, how they impact the two production system. Yeah, the black one is ethanol production from a forest, and the gray one is ethanol production from the corn stalk. We can see that the impact is here. Comparing 1 kilo bio-4 ethanol production with 1 kilo thermo ethanol production based on the impact method on LCA. If we look at the graph, you can see that bioethanol production, bio-4, give more impact compared to the corn thermo and ethanol production. Yeah, on human health and ecosystem quality and climate change also. The corn is better, and resources application also, the corn stock is better compared to use the to make ethanol from the forest residue. Yeah, this is also method from LCA. I don't want to make a detailed explanation on this. Yeah. So that is this crossing. Why is the green technology necessary? Green technology primary aim is to control global warming and reduce the greenhouse effect. The principal concept is to develop innovative invention that do not affect the natural resources. It will result in less damage to human, animal, and our planet's overall health. Now it is obvious that our world is beginning to suffocate from all the waste that we produce. But if there is a will, then there is a way to make this problem much smaller. The successful use of green technology will make a bigger contribution toward reducing emission. This is why many developed and some of developing countries are now transitioning toward this form of technology to help protect them from harmful impact on the climate. So the pollution problem or green technology, however, is a relatively new idea. It is becoming more common now because people have begun to realize that we are actually destroying our world. Green technology has become one of the employment sectors with the fastest growth. And because protecting our world has become important, green technology is certainly far more than a trend that it will soon pass. The green technology also trying to provide alternative sources of energy which do not deplete critical fossil fuel. This is the challenge for the development of green technology, lack of information, lack of human resources and skill, high implementation costs, lack of knowledge about alternative process technologies, lack of knowledge about alternative chemical and raw material input, low national diffusion capacity for green technology, and inadequate policy motivation. This is the challenge for us to develop green technology for the better life. So thank you very much. Green technology is in biorefinery is necessary. This is my conclusion. Thank you.
Okay, thank you very much for Professor Nofisher. That is a attractive presentation, I think. So we are going to the discussion section. Maybe you have some curiosity about a question regarding the green technology for biomass and biorefinery. Please let me know. You can drop the question in the chat box or raise hand or open mic, maybe. We have still a lot of time.
Sir, can I ask a question?
Okay, please. From Astuti? Oh, no. From... Okay, please, if you have a question.
Please mention your name and...
My name is Ian Parlina. I'm from Brian. My question is, according to your experience and knowledge, what is actually the most suitable green technology to be implemented in biorefinery? I mean, the biorefinery itself is actually considered as a green technology, right? If I'm not mistaken, because the purpose of the biorefinery itself is to replace the fossil fuel and to reduce the greenhouse gas emission. But if you say that actually we need green technology implemented in biorefinery, actually which part of the biorefinery that could be could be optimized by this green technology utilization? Is this in the raw material preparation part, or it is in the process fermentation, for example, or the purification? So what step that actually what step in the biorefinery that we could implement the green technology? I think that is my question for now.
Okay, thank you. Maybe Prof. Nofizar directly answer the questions. You get the point.
Yeah. Thank you very much for the question, Parina. It's a very good question, and it's not easy to answer. My objective of my presentation is to build awareness that the importance of green technology. So actually, there are many green technology in biorefinery, and many industry have done, but I cannot inform you in detail. The basic principle of green technology, how to use the less input. Ya, bagaimana kita mengurangi input, energy, water, and chemical. That's the principle. The more energy use, the more water use, the more chemical use will increase the impact. This is the basic principle of life cycle assessment. And the other one is the other principle is how to recycle. How to recycle of the production system, and how to reduce how to make less input, how to reduce the energy, how to reduce the chemical, and how to reduce the water consumption, and how to minimize the resources application. So this is the strategy for green technology. So the intinya adalah bagaimana kita di dalam menggunakan dalam praktek biorefinery kita memikirkan bagaimana dampak itu sekecil mungkin, dampak kepada lingkungan, dampak kepada manusia, dan dampak kepada kehidupan. Jadi intinya yang ingin sampaikan di sini adalah to membangun awareness, pentingnya kita menggunakan green technology. So I don't have the more detailed information on what kind of technology have been used in biorefinery. So we can explore more in detail. Thank you.
Okay, thank you, Prof. Nofizar. Is it okay, Ms. Iin?
Can I ask one more question?
Okay, of course.
My second question is about the cost. You know that actually you said in your presentation that we have been struggling regarding the how we can compile the the cost because the economic feasibility is I think the most the hardest problem in implementing the green technology. So in your opinion, Professor, is there any way to to solve this problem for the economic feasibility?
Yeah, in sustainable way, we have to aware about the social, technical, environment, and economic. So this is sustainable. The people say that 3E: economy, ecology, and economy. Like economy, ecology, and equity, social. So in life cycle assessment method, we can assess the economic impact of the technology. We can decide which one is feasible technology to apply. In the name of the method is life cycle cost analysis. So this is the tool we can use for calculate the economical problem in our technology. So in application of biorefinery, economic aspect is not easy because the life is so expensive, and but in technically we can use the tool to assess the economic problem in technology.
Okay, thank you, Prof. Nafizar. Is it clear enough, Ms. Ian, for the answer?
So we can use like a tool to assess like some kind of technology, and then we have the result and compare one technology to other based on that tool, right? If I'm not mistaken.
Yeah, exactly. Sure.
Thank you,
Yeah,
sir.
yeah. We can work together on that. If you have wearable technology, if you have a different method on production of the product, we can compare which technology is environmentally better and economically feasible in life cycle cost assessment, LCCA. You can explore in more detail in Google. You can life cycle cost analysis. Yeah, we need this analysis before introduce this technology to people. Here.
Okay, thank you. We have one more question from Perfectly Mystics from Miss Astuti. She asks about what the software was used for LCA.
Yeah, many software now available commercially. We can use Simapro or Gabi, many softwares. But the most famous software and most popular is Simapro. I use Simapro, and Brain have LCA center in Serpong.
Okay.
They have the software.
Simapro software, right?
Yeah.
Yes. Is the database in the software appropriate for Indonesian condition? I think something like feature or etc. like this.
Yeah, and this is a problem. This is a problem because we don't have the Indonesian data, but we can use the other the data like other countries with the same situation in Indonesia. So it's this is the next job for Brain to develop the LCA data from Indonesian case.
Yes, I think that is a main challenge for us.
Yeah.
Okay, we have a question from Hana Nurfitriana. How does green technology help the economy? Is green technology should be related to circular economy or not?
Yeah.
Maybe you have some perception or perspective.
Yeah. Yeah. Green technologies. Related to the circular economy. Yeah. Yeah. And life as circular assessment is the basis of circular economy, because we calculate the impact of the system in life cycle of the product. Yeah. This is I will ask a question from Vira Putioso on palm oil. Yeah, we can calculate the impact of production like palm oil. We can calculate the CO2 emission from 1 liter of CPO, for example. We can calculate the CO2 emission from 1 liter of biodiesel, something like this, and we can calculate the impact of palm oil production to human life, to health, and other impact. Yeah.
Okay. Thank you, Prof. Nafisa. Okay, Ms. Vira, is it clear enough for the answer? Maybe you have some question or other.
Enough, thank you. Thank you,
Okay.
Prof.
Yeah, thank you.
Okay, we have still a lot of time, maybe 10 minutes for discussion. Maybe you have a question, please raise your hand, open mic, something like that.
Yeah, I want to make more information on how important is green technologies and the challenge for development in green technologies in Indonesian case probably. But we lack of information. Yeah, many people lack of information on green technologies, and also lack of human resources, skill, and also that's the implementation cost of the green technology also high, and this is a challenge for us in biorefinery case, and lack of knowledge about alternative process technologies. Probably for example, which chemical is better to use for extraction, which chemical is environmentally friendly to make the product, and lack of knowledge about alternative chemical and raw material input. Yeah, which input is better. This is our challenge. Yeah, and low national diffusion capacity for green technology. Yeah? And LCA, Indonesian LCA start last 10 years. Is Indonesia have adopted the LCA system now, and we hope this next will be better to aware about the environment effect of the products, and we need the policy motivation how to develop the technology. So as researchers, as students, and as a businessman, we have to be aware that green technology is important, and we have to apply the green technology to make the life better, to make an environment good and to decrease the impact on climate change and to reduce emission and etc. That's my point, and the importance of green technology application in our production.
Okay, thank you. Okay, I think there's no question anymore. So we are going to the closing section of this kind of panel discussion. So I have reached the end of this panel discussion. Based on the results of the discussion, I can highlight some main conclusions as follow. Why green technology is necessary? Because green technology primary aim is to control global warming and reduce the greenhouse effect. The principal concept is to develop innovative invention that do not affect the natural resources. Green technology is the technology that has the potential to significantly improve environmental performance relative to other technologies. About the green biorefinery, our multi-product system which utilize green biomass as an abundant and versatile raw material for the manufacture of industrial product. In the end, I am as the moderator, I acknowledge to the speaker for sharing about the green technology for biomass and biorefinery. In addition to all participants, I would like to convey my sincere thanks for their active participation and cooperations. Before we close this discussion panel, I want to give Prof. Nafizar some like appreciation certificate.
Thank you, Nanda, for the certificate. Thank you for the Dean and the Chairman of OC, Dr. Sophia. Thank you very much. Thank you, all people, all participants this afternoon.
Okay, thank you, Prof. Nafizar. Hopefully, this discussion will provide a benefit for us and contribution to the effective and efficient sustainable green technology. I'm Nanda. See you. I send back to the committee.
Thank you, Nanda.
Thank you.
Okay.
Thank you very much, Professor Dr. Nafizar Nazir, for giving such an informative and comprehensive presentation.
Thank you, Dr. M. Akhilonanda, for being our wonderful moderator in the session. Before we end the session, we would like to present Dr. M. Akhilonanda with a certificate of appreciation for doing a great job today. And we will take a picture from 1, 2, 3.
Okay, thank you so much. Okay. For our last session, we will talk about recent finding of chemometrics in food science, and this session will be led by a moderator. Our moderator for this session is Dr. Yuan Nurhamiah. Allow me to read her short bio. Dr. Yuan Nurhamiah is expertise in material physics and polymerical techniques, graduated in Queen's University, Belfast, with recent article research in advances in material science and engineering, macromolecular materials and engineering, Springer proceedings in physics, macromolecular chemistry and physics, ACS applied materials and interfaces, McClellan B sustainable future for human security, etc.
To Dr. Yayan Nurhamia, the time and screen is yours.
Thank you, MC, for the introduction. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. My name is Yayan Nurhamia. I will be your moderator for this last session. So it is such a great pleasure that I will be the moderator for this second virtual mobility program, collaboration of FDIP Unpad, BRIN, PKRBR, and SET Network. So before we start the session, I would like to remind you that we would love to deliver an interactive session between you and the speakers. Therefore, for the participant, we invite you to turn on your camera once we start and beginning the Q&A session. But if you are shy to turn your camera on, you may use the raise hand button on your screen to deliver your question. For this session, we will inviting our distinguished speaker, Professor Dr. Abdurrahman Aid Kadur, who is joining with us. Good morning, Professor Kadur. Are you with us?
Good morning. Yes, I'm here.
Okay.
Do
Thank
you
you for
hear me?
joining us. Hello. Yeah.
Yeah. Okay.
Professor, thank you for joining us today. I think it is a morning in the France, right?
Yes, it's 9 o'clock.
9 o'clock. Yeah, it's the right time. So let me introduce Professor Kadur. Let me read his bio. So Professor Kadur is a professor in food science and technology science with H-index 15. And also he is in the teaching department in the University. And also he spent his education in Ph.D. in Montpellier Sub-Agro Institute, Master in Food Process Engineering in University of Montpellier as well, and also Engineering School in Bordeaux. So now he is a full professor since 2020. And he has various skills, including spectroscopy, chromatography, food biochemistry, process, chemometrics, and multispectral image. He also has experience of more than 200 hours of teaching per year. And also he has 44 international papers in Impact Journal. Okay, so I would like to give thanks to Professor Kadur for joining us today. So I think, Professor Kadur, are you ready for your presentation?
Yes, I'm going to share my.
So Professor Kadur will deliver his presentation with the title Recent Finding of Chemometrics in Food Science. To Professor Kadur, the time is yours.
Okay, so I will share my my screen. Okay, so. So thank you. I would like first to thank the committee for his invitation in order to present some results of my research activities. So firstly, my presentation will be divided in 3 parts. I will firstly talk about my institution, secondly about my research units, and thirdly, I will present you some examples of research projects in which we used chemometrics and also spectroscopy in order to predict the quality of food products or to make a process analytical to monitor food process. So firstly, so a very quick introduction concerning my institution. So my institution is Agro-Industrial, so it's composed of 2 campuses, and it contains 3 main programs. So my institution is located, so of course, in France, in two towns, Clermont-Ferrand and Lyon. So we have more than 1,000 students, more than 100 teachers and associate professors, and more than 400 technical and administrative staff. So we are, of course, training students. We are organized in different departments on agriculture and landscape, on food quality and economics, for example, or on fundamental science. We have also different research activities, of course. We are organized in research units. So we have 9 joint research units, 3 research units that are specific to AgroSup, and 6 research units with which our researchers are affiliated as individual scientists. And we have also different expertise because we have analytical laboratories, different center of expertise, also documentation centers, and 1 museum of veterinary education that is located in the Lyon town. So our programs, we have veterinary medicine program, agriculture engineering program, and veterinary public health inspection program. We propose also different masters and professional bachelors for our students, and we also propose continuing education courses for different professionals. Our research activities is centered on global health, and we have 3 axes. One, agroecological transition in agriculture and food systems. Another one on quality of life for humans and animals. And the last one concerning the management of health risks. So here you have a detail of the different research unit that we have. So for example, we have a research unit on grassland ecosystem, and I'm working on the cheese research units. So we have a very high diversity of research.
Sorry, Professor.
Yes.
Sorry, Professor
Yes.
Kadur, we cannot
Yes.
see your presentation.
Oh, sorry.
So you haven't shared your screen. Yeah.
Oh, sorry.
Yeah.
Trend.
Can you... Yes. Yeah. Now
Is it okay now?
Yeah. You just yeah, full screen. Yeah, that one. Yes. Thank you.
Is it okay?
Yes,
I'm
it's
sorry.
okay.
I'm sorry.
You may.
So here you have our different center of expertise. So we have Center for Veterinary Pharmacovigilance in Lyon. We have also Chay in animal welfare, for example, and we have also 8 analytical laboratories and clinical laboratories, food characterization laboratories, and we have also national reference laboratories for Escherichia coli. So concerning now my research unit, so my research unit is working principally on cheese and more specifically on traditional cheese. So we are a research unit that is located in 2 towns, Clermont-Ferrand, of course, but also Aurillac. And this research unit is associated to different institutions, the university, INRAE, that I think you know, and of course, AgroSup. So my research unit is a multidisciplinary research unit. So we have different scientific expertise on microorganism and ecology, on nutrition, on biochemical and biophysical analysis, sensory functionality, food technology, for example, microbial interaction and mechanisms. A very high diversity of expertise. So we are working from the milk production to the consumer, and we are organized in 2 axes, and we have different research projects. So, for example, here we are studying the microbial flows, the microbial communities from the milk production to the consumers. We have also other projects that are in looking to the impact of the mineral fraction on cheese quality. And we have also other subjects that are more focused on human nutrition and human health benefits. So what I'm doing in this research unit, I'm try to study the link between, to have a better understanding of the link between the structure, texture, microorganism, and functional properties of the cheese. And I use principally the modification of formulation and the process in order to have some information concerning the link between those different scales in the cheese product. And here you have different research projects that I have been implied in. So, for example, we have studied the effect of salt content and its variation in the characteristic of the cheeses. We have also focused on the blending of milk from different species in order to see what is the effect of the blending of milk before obtaining cheese concerning its sensory properties, for example. And we are also, I'm also working on the modulation of antioxidant content of the cheese by modifying the animal food, I'll say, and also by adding some antioxidant molecules in the milk before coagulation. So I have also another activity concerning the development of rapid measurements techniques or method for the authentication of food products and also for the prediction or evaluation of the food products quality. So this is very important because, you know, we have different frauds on food, and we have to identify if the food that we have in the supermarkets are really the food that is mentioned in the packaging, for example. So why I'm studying the development or interested in the development of rapid measurement methods. So as I said it before, it's for identifying the food quality, for authentication of the foods also. And in order to study this subject, I have to define, for example, what is the best spectroscopic technique or method, what is the accuracy, what is also the chemometric tool that is the best tool in order to analyze the data. And I have also to look at the possibility to transpose the tools, our laboratory tools, to tools that are more suitable for industrial environments. So in order to do these studies, I'm using different biophysics tools, so rheology, spectroscopy, imaging, chemometrics, and I will define what is chemometrics just after, and also, of course, food science and principally biochemistry. So a focus on chemometrics. What is chemometrics? So chemometrics is a chemical discipline that uses mathematical, statistical, and other methods employing formal logic to design or select optimal measurements, procedure, and experiments, and to provide maximum relevant chemical information about analyzing chemical data. So I'm using chemometrics in order to simplify, in order to extract the most important informations from my data in order to build some predictive models for discriminating samples or for predicting the quality of the samples. So here I have noted a difference between chemometrics and statistics. So in chemometrics, we are not, yes, we have a very few hypotheses, so contrary to statistics. And however, we have always different parameters to adjust, meaning that we have, for example, to correct or to decrease the noise from our data by smoothing the data, for example. We have to decrease also the baseline variation of between spectra. So if we strip spectra, we have to correct this baseline. And we have also different steps before building the predictive models. For example, we have to calibrate the model, to validate the model, and to test the model. So this calibration, validation, and testing of the model are very, very important in chemometrics and in the building of our predictive tools. So here are some examples of chemometric tools. I think that you know some of them, of course. So we have univariate chemometric tools, exploratory ones and predictive ones. So for the exploratory ones, I think you know principal component analysis and canonical correlation analysis. So the PCA, the objective is to to describe the link between the samples and to see if we have different groups concerning the samples that we analyze. For the CCA, the canonical correlation analysis, its objective is to identify the link between two data tables. For example, if you measure the biochemical composition of a sample, and if you are also on those same samples make spectral measurements, you can use CCA in order to see if there is a link between the two data tables. And we have also the predictive chemometric tools. The chemometric tools that are very spread is a PLS, so partial least square regression, and partial least square discriminant analysis. So PLSR is enables to predict one characteristics of samples from Harvard data. And in my studies, I predict the composition of the samples, for example, from spectra. Okay, the partial least square discriminant analysis is a method that allows you to predict if a sample is associated to to different groups. So if it's more associated to a group A or to a group B, for example. So after this very brief and rapid introduction, I will present you different examples concerning the use of chemometrics, spectral data, in order to monitor some food process or to adjust food formulations or to predict some food qualities. So microbial spoilage, for example, here, and also to authenticate cheese. So I have chosen to talk you about 3 food matrices, so flour, cheese, and beef meats. And also, I'm going to talk you about the different chemometric tools that we used in those different examples. So principal component analysis, common dimension analysis, partial least square, interval partial least square, and partial least square discriminant analysis. And we also use different chemometrics, spectral techniques. So the near-infrared, fluorescence, middle infrared, and also multispectral imaging. So concerning the first example, how we can use spectral methods in order to monitor process. If we use spectral methods in order to monitor process, we call this process analytical technology. Okay, and I decided to present you how we can monitor flour mixing by using near spectroscopy. So here is the plan for this part. Why we have done this study? We have done this study because the mixing structuration of flour in the presence of water is monitored by the know-how, generally by the know-how of the operator that will say, okay, now my product is well structured and I can use it, for example, to make pasta, to make bread, or to separate from gluten from starch. So we have also another possibility to identify the optimal point for producing our final product is to make sampling, meaning that we have to extract some samples during the process. And this is not always very suitable for ongoing process. It will take time, it can be dangerous, etc. So here I will present you how we have used near-infrared spectroscopy in order to monitor different process. So process that is used to obtain pasta. For example, the process that is used to obtain bread, and the process that is used to separate gluten from starch. We use, of course, a near-infrared spectroscopy. I will show you how we use near-infrared spectroscopy. So the near-infrared spectroscopy was used between 800 nanometers and 2500 nanometers. Why we use this range? Because we have different information concerning molecular vibrations, and we made the hypothesis that those vibrations can give us an indication concerning the evolution of the product during is mixing with water. So before performing this project, some studies have been done previously on bread dough, but no studies were done on crumbling dough or diluted dough. So diluted dough is the one that is used to separate gluten from starch. Crumbling dough is the one that is used to make couscous, for example, or to make pasta. So we used here an infrared spectrometer from Thermo Fisher, and here you have the fiber optic probe that we put it over the dough. So we didn't have a contact between the dough and the probe. So we have a non-invasive measurement of the product during this processing. So we have also we use a different type of mixers. So here we have an oblique mixer, I will say. Here we have a spiral mixer, and here we have a horizontal mixer. In order to see if the near-infrared spectroscopy can be used in different configurations, in different water contents, etc. So after recording the different spectra from the process, we use the principal component analysis in order to reduce the number of variables, because we have spectra, and when you have a spectra, you have a very high number of variables. And in order also to have a synthetic overview of what is going on concerning the spectra, because principal component analysis will give us a synthetic overview of the spectral distribution of the samples during the process. So we'll have two kinds of information when we will use principal component analysis. If we analyze the scores during the processing time, we'll have a kinetic information concerning the variation of the spectra. And if we look to the loadings after applying a principal component analysis, we will have access to a chemical information, meaning what are the wavelengths that are the most important to monitor the process during the product processing. Concerning the results now, here you have the results concerning after applying the principal component analysis for the different process that we studied. So here you have the spectra. After applying principal component analysis, we obtained, as I said it before, the scores and the loadings. So the scores, if we look to the variation of the scores during the time, we can see that we have a curve for all the processes, and that we can identify a point where the rates of the evolution of the curves is changing a lot. And we identified those times has the best times, the best processing time to obtain the best final food products. So we have made also modelization. So here you have the equation that we used, for example, for bread mixing, in order to identify the T0 that is associated to the best product. So here, bread. We also made some reference measurements. Here we have an example for the crumbly dough. We have measured also the evolution of the size of the particles during the crumbly dough formation, and we identified that the time T0 that we identified after principal component analysis of the spectra is highly correlated with the size distribution of the different particles that we have in our mixer. So we have a higher link between the chemical information and the physical information that we extracted from our NE spectra. So in order to make a very brief conclusion concerning this study, we identified that NE spectroscopy is adapted to monitor inline, so different kneading process, kneading of the bread dough, of the diluted dough, and of the crumbly dough. And we also associated the variation of the different spectra to physicochemical modifications. And we have identified different bands, NE bands, that are associated to chemical modification of the dough during mixing. For example, water molecules, starch, proteins, etc. So now I will talk to you about another example where we try to optimize, I will say, the formulation of cheese products by using spectral data and a chemometric tool that is called COMDIM. The objective was to try to decrease the salt content of the cheeses without modifying its sensory properties and also its technological properties. For example, its behavior when we heat it. A brief overview of what I'm going to present you. So a brief context. After I will show you the process that we use to make cheese, the techniques that we use to analyze the cheeses, and also some elements concerning the COMDIM chemometric tool. And I will after show you some results. So why we have conducted this project is to, because, we are eating a lot of salts in our diets. So in Europe, I don't know in Indonesia if it's the same thing, but in Europe we are eating more salt than necessary. And we have identified that 3 products are contributing to the salt intake of a human being. And in these 3 products, we can find the cheeses. So why reducing the salt intake? Because it causes different health concerns. High blood pressure, for example, kidney disorder, etc. So it will be very interesting to reduce the salt content of the cheeses in order to reduce our salt intake. But reducing the salt content of the cheese cannot be done simply, because the salts, in the cheese is very important, because it reduces the water activity. And therefore, it regulates the microbial growth and it preserves the cheese and the safety of the cheese. But it is also very important because it has an effect on the cooking properties of the cheese and on the rheology and texture properties of the cheese, and also to a link with the flavor release and aroma release. So we decided to in order to decrease the salt content of the cheese without modifying all the points that I presented you before, we decided to make a study from the molecular scale to the macroscopic scale. So we focused on the composition of the cheese. We are also focused on the molecular structure of the cheese and also on the texture and the functional properties of the cheese. So we have also, during this project, focused on the structure because in the literature, we didn't have a lot of information concerning the molecular structure. What is the effect of the salt on the molecular structure? And the molecular structure is very important also in the development of the cheese quality, for example, the appearance, the nutritional value, the texture perception, etc. So it was very important for us also to have an idea of the effect of modification of the salt content of the cheese on this scale level. So as you can see it here, we wanted to study different scales levels, and we wanted also to make a link between between all those scales levels. So in order to make a link between those different scales, we use the COMDIM method that allow you to analyze so the link between different data tables and also to identify what is the data table that is the most important for the property that is modified in the cheese. So now concerning some materials and methods. So we worked on hard cheese that is called Cantal cheese. It's close to the cheddar cheese, perhaps that you know this cheese, cheddar. And we used 5 kinds of salting. So we salted with sodium. So we had 2 concentration, 2%, 1%. So 0.5% here of sodium. And we also tried to make a substitution of part of the sodium by potassium here. So we replaced 0.5% of sodium by potassium, and here 1% of sodium by 1% of potassium. And we also ripened the cheese during 2 different times, so 5 days and 50 days. So the standard is the 2% NaCl. So we made different measurements. Different measurements concerning the composition. For 14 chemical and physicochemical parameters were measured. So mineral content, moisture, pH, etc. We also made spectral measurements in order to have access to the molecular structure of the components that we can find in cheese. We also made mid-infrared measurements. And during the measurements, we also made a variation of the temperature between 20 and 60 degrees C in order to have an idea of the behavior of the cheese during eating, because cheese can be used also in pizza, etc., or in soup. So we were interested to know what is the effect of the temperature on the cheese. And we also measured the texture properties of the cheese. We measured also the color properties of the cheese, and we made also dynamic rheology rheology in order to have access of the melting temperature of the cheese and so other rheological parameters. And we use COMDIM. So in order to put in relation the different data tables. So COMDIM is also called canonical correlation and specific weight analysis. Okay, you can find this in the literature. So what is COMDIM? As I presented you before, COMDIM will give us the possibility to analyze in one shot all the data that we measured on our samples. So I said you that we made middle infrared analysis on different temperatures, fluorescence analysis of different temperatures, dynamic rheology also. We measured other parameters, so melting temperatures. We measured also physicochemical and composition of our cheeses, texture profile analysis, and the color. So we have at the end 31 data tables, and we wanted to analyze them in one shot and to see what is the link between all those levels, scale levels, concerning our cheeses. So when we apply COMDIM, we'll have three outcomes. One outcome that we call saliences, another one that we call scores, and last one that we call loadings. So the saliences will allow us to identify what is the table that is contributing the most to the distribution of the samples. So the distribution of the samples can be seen in the scores outcome, and the loadings will allow us to identify what is the variables in the tables that are the most important. For example, if I take the table of texture profile analysis, that I think it's very simple, we will identify by looking to the loadings what is the variable that is the most important, meaning if is it for example shawiness, is it gumminess, or hardness of the sample that is the most important, and that will explain the distribution of our different cheese samples. So here you have the results after performing COMDIM on our different data tables. We identified that 6 common components explained 98% of the data variability between of our data, of all our data tables. So I'm not going to present you all those results, but we will focus just on 3 common components in order to show you what can be interesting to see and what are the results that are interesting when we apply COMDIM to our samples. So if we look to the first component, so the first component is associated to viscoelastic properties of the samples because it is the highest here data tables that are identified in the saliences, so dynamic rheology. And if we look to the loadings, we also can see that all the measurements that have been done between 20 and 60 degrees C are important. So the elastic properties, viscous properties, and viscosity, dynamic viscosity are all very important and therefore are changing when we are changing the salt formulation of the cheese. So what we can see when you look to the scores distribution, we can see that if we decrease the sodium content of the cheese, here you have the standard. If we decrease the concentration, the sodium concentration of the cheese, we will have a decrease in the different viscoelastic properties of the cheeses. So we can say that the cheeses are less elastic and presented a lower resistance to the deformation when we decrease the sodium content. When we replace parts of the sodium by potassium, we will see that we will have an increase in the viscoelastic properties of the cheese. So you can say that our cheeses are more elastic and presented a higher resistance to the deformation. And we can have the same conclusions for the two ripening time. So here you have the result for the 5 days ripening time. And here we have the results for the 50 days ripening time. 15 days, sorry. So concerning the second common component, we can see here that the data table that is associated to fluorescence spectroscopy is the highest one. So it is this data table that will explain the distribution of the samples in the scores map. And here, if we look to the loadings, we can see also that all the fluorescence probes that we have naturally in the cheese are modified by the salt, the modification of the salt content of the cheese. So what we can say here after analyzing those data, we can say that decreasing the concentration of sodium will increase or modify the molecular structure of the different components that we have in the cheese. So the lipids, because vitamin A is associated to the lipids, will have also a modification of the proteins, because here we have a modification of the fluorescence of the tryptophan. And if we make a substitution of the sodium by potassium, we will have an increase, a decrease of the, I will say the intensity of the bands, fluorescence bands that are associated to the different fluorophores that we identified. So vitamin A, tryptophan, and riboflavin. So now concerning the last common component. So we can see here in the saliences that this component is yes, we can see that the result associated to the texture profile analysis, the melting temperature, and also a little bit to the color, that that all those data tables are explaining the variation or the distribution of the data that we have in the score map. And if we look to the loadings, we can identify more precisely what is important. So the cheese melting is important, the hardness, the cohesiveness, and the showiness are important concerning the texture profile analysis. And we can say concerning the color, that is the yellowness and the redness also, that are important, but the yellowness is more important. So the conclusion here that we can give is that the decrease in the sodium content and the increase in its substitution by potassium will induce a decrease of the cheese melting temperatures. Okay, that we have here. A decrease of the organoleptic quality of the cheese, because we have a modification of the hardness, cohesiveness, showiness, and also the color of the cheese product. So concerning the conclusion, so of course we can say that the CONDIM is a very interesting in order to analyze and combine different data tables that we will acquire after different analysis on food sample, here cheese. And we have also demonstrated, because this was not done before, that spectral methods are very suitable in order to identify the effect of salt content on the molecular structure of the cheese. We have also identified that the reduction of sodium and its substitution by potassium modifies so different characteristics of the cheese, its physicochemical properties, molecular structure and texture, and also the color and its thermal behavior, because we talked about the melting of the cheese. And we have also identified that if we want to maintain the same properties as the standard on the cheese, we have not to decrease the sodium content under 50%, and we also it is we also not it is also we recommend also not to increase the substitution of the sodium by potassium over 25%. So another example now. I wanted also to talk to you about some how we can use spectral methods in order to predict some characteristics of food samples. So this project is on meats. So as you saw it, I worked on different food matrices, and at the beginning I said you that I was in a research unit that is principally working on cheese, but I have the possibility to work on different food matrices because I'm the dean of biophysics laboratory that is also working with different industries and other research units. That's so this will allow me to work on other food matrices. So I wanted to talk to you about the possibilities of using spectral methods in order to predict some quality parameters of food products. And here I choose to talk to you about the microbial, the possibility of using fluorescence spectroscopy in order to predict the microbial spoilage of meats. So here the plan. So why we have conducted this project is so the objective of this project was to develop a tool that a very simple tool that can be used by stakeholders very simply in order to allow them to analyze a lot of meat products and a lot of carcass of meat products, animals, because in the past and also today, the technique that is used is based on observation, and the observation of an expert is not always suitable for detecting defects on food samples, and it is also very difficult to analyze all the products, and also to detect all the diseases that can be on the meat product. So we wanted in this project to propose an alternative measurement or technique that can for sanitary quality assessment that can be used on or at line. So we decided to use fluorescence spectroscopy, and we used a laboratory device that allowed us to record spectra between 250 nanometers and 500 nanometers. We use different offsets of excitation from 20 nanometers to 180 nanometers, meaning that we excited at wavelengths, and we recorded the fluorescence, the emission of fluorescence at different ranges. So we recorded a very high number of spectra, and we used a partial least square and interval partial least square in order to make our predictive models. And of course, we made a calibration and a validation of our models of prediction. So we decided to use a fluorescence because the fluorescence is very sensitive compared to infrared spectroscopy, for example, and we wanted to predict the microbiological loads that can be present in meat. So we hypothesized that using fluorescence can be a very interesting tool for this task. So we worked on minced beef. So it's a model minced beef. And we packed the different minced beef samples on aerobical conditions and vacuum conditions. And we also stored them at different temperatures from 0 to 50 degrees C. And we made different microbiological analysis for all the samples. So here you have the sampling that we used, and we made on the same sample spectral measurements and microbiological counts in order to make the link between those two kinds of measurements. So here you have the different loads concerning microorganisms that we measured. So we were interested by Pseudomonas, lactic acid bacteria, yeast and molds, and etc. And first of all, we recorded the fluorescence spectra, and we identified that the fluorescence intensity of the spectra were varying depending on the storage time. So we concluded that this variation can be associated both to the development of microorganisms, but also to the physicochemical modifications that are induced by the development of microorganisms. After observing that, we said, okay, perhaps we can predict the microbiological loads, and we performed predictive models by using partial least square chemometric tool. And for the calibration and for the validation, we obtained a very high coefficient of determinations that permitted us to say that we have a very good link between the variation of the fluorescence spectra and the microbiological loads of the meat products. So I said to you at the beginning that our objective was also to develop an online or inline tool in order for the stakeholders to be simply used inline and online in the plates. And for developing this device, we use interval partial least square, meaning that we build different predictive models by focusing on a very small range of wavelengths. And after performing interval partial least square, we then identified different ranges that were very interesting for building the predictive models. And after that, we performed exactly the same study that I presented to you before. So we selected the minced beef, we stored it in different conditions, different temperatures, and we measured also the microbiological loads of those meats in order to see if our device was also interesting to predict microbiological loads. So in order to develop this device, we, as I said it before, we identified different ranges that were very interesting for predicting the microbiological loads, and we buy different LEDs that were located in the ranges that we previously identified. So we use 3 LEDs. So here you have the 3 LEDs that we used in this device. So we had 3 devices, one for each LED. And then we tested the accuracy of this device, this small device, to predict the microbiological loads. And we also identified that we had a very high correlation between the loads and the spectra that we recorded by this small device. So concerning the conclusion, so we can say that fluorescence spectroscopy is very interesting for predicting microorganisms loads that can be present in meats. So we use the model as minced meat, and We also noted that for each load, for example, Pseudomonas lactic acid bacteria, total viable counts, we had specific wavelengths that were identified in the predictive models. So we can also have specific bands that are associated to each load. So at the end, of course, we developed a miniature prototype that can be used online for predicting microbiological loads of meat. The last study, so I have five minutes to finish. So the last study concerned the authentication of cheese by multispectral imaging. So here we have another spectral tool that can be used to make images. And we use also partial discrete discriminant analysis, so another chemometric tool in order to make the discrimination between the cheese samples. So the plan, why conducting this study? Because I don't know if it's the case in Indonesia, but in France, you know, and in Europe, you have some samples are identified by labels, and this label is associated to a know-how, to a specific process, and also to a specific quality. And it is very important to make the difference between those samples and classical, those food products and classical food products, because the food products that have a level of quality have a higher price in the markets compared to the other food products that do not have those labels. So we decided to perform this study on blue vein cheese because those blue vein cheese have a lot of labels, and therefore it was very important to discriminate them. Firstly, between them, because we have different blue vein cheeses, and also from the blue vein cheeses that have a label to the other cheeses. But what is the tool that we use? We use multispectral imaging. So what is multispectral imaging is we have this device in my laboratory. It's a video metal lab that allow you to record different images of the sample in different wavelengths. So we have 19 wavelengths that are located in different region of the electromagnetic spectrum. So in the near UV, in the visible, and in the near region. So here you have all the LEDs that are in this device. And so we can have 19 images of the same sample. After that, so we use 17 samples of blue cheese, so of different categories, and we made measurements by a video metal lab, and we also made chemical analysis on those samples, and we made.
Professor,
yes.
Apologize. Your time actually is up, so you may speed up your presentation.
Okay, so I will speed up. So we made a modification of the images in order to analyze their grain level, and by doing that, we had the possibility to extract, the shape of the blue veins that are in the cheese, and we use those shapes in order to make a discrimination of the cheese samples. And here you have the result of the discrimination, and we have identified that just by analyzing the blue veins shapes, we can discriminate the different cheeses that we studied. And also by using the device, we can predict the different chemical parameters of the cheese, so the dry matter, the fats, etc. I have finished. Sorry for being late.
Okay, thank you, Professor. Your great presentation. Thank you for sharing your valuable knowledge. So actually, I'm not really familiar with food science, even though I am a material scientist. So even though our object is different, but the technical and also characterization is, I think it's similar. So thank you so much for your time, for sharing your knowledge. So I would like to invite the audience here, the participant, if you like, if you have some question to Professor Kadur, you may raise your hand. Or yeah. If you have question to Professor Kadur, you can raise your hand and I will call your name. So I will. So this is from Astuti, Professor, in the chat. So have you applied these methods for halal food? Have you ever considered your method in the spectroscopy or fluorescence for halal food?
No, in my research projects, no, but I know that some studies have been done concerning this topic, and they identified that it was possible to differentiate between halal and non-halal meats. For example, they made a mixture of beef meats and pork meats, for example, and they identified that if we have some pork in beef meats, we can identify this adulteration also concerning halal and non-halal meats. But I don't know what is the level of detection of those methods concerning this topic.
Okay. Thank you for your question. So I have a question. So to decrease the salt in cheese, you substitute the cheese with potassium, right?
Yes.
And you said the structure is not different with the standard. But so how about the taste? Has it influenced the taste?
Yeah, yes, because I didn't present the results concerning sensory analysis, but we have done also sensory analysis by a panel that is expert, and we identified that, as I said it during my presentation, that if we do not substitute over 25% of sodium by potassium, we don't have consequences concerning the sensory properties of the cheese. So we have the same properties as the standard.
Okay, so you have same properties as the standard. So do we have another question to Professor Kadur?
Yes.
Yes, do we have from the participants? Okay. So I have a question as well. So I use FTIR instead of NIR in my research. Mm-hmm. So it is also an infrared spectroscopy as well. So I would like to give you. I would like to ask you about the first research. So what kind of analysis you can get from NIR or explanation from the absorption band from NIR?
I didn't hear the end of the question because can you repeat the end of the question?
So what kind of explanation usually you give from the NIR data?
Concerning the first study, you mean, that I presented?
Yeah. I think the first one is about the flower mixing.
Yes. Concerning the chemical analysis of, say, of our spectra, I presented only the raw spectra. When you analyze the raw spectra, it is very difficult to extract chemical information from your knee spectra. By analyzing the raw spectra, we just see, the bands that are associated to water at 1,480 and 90, for example, and 250 nanometers. But if we transform the spectra by applying a second derivative, for example, you will have higher bands that will appear, and those bands can be associated more closely to chemical modification of your products. And what we have identified is that when we monitoring the flour mixing process with water, we have the different bands that are associated to the water, I will say the water states, because you have some free water, I will say, and some water that is associated to chemical component of the flour. So for example, proteins that are forming gluten during mixing, for example, or also with starch. So we have identified a starch band, water band, and also protein bands. And by analyzing the evolution, we can associate it also those bands to the structuration of the gluten matrix.
Yeah, okay. Thank you for
But
your answer.
yes,
Yeah.
but it is better to use infrared, middle infrared, if you want to have a higher picture of your chemical modifications.
Okay. Thank you for your answer. So I think this is the last question from the chat. So from Hannah, how can you analyze microbes specifically using spectroscopy method? How can you analyze microbes specifically using spectroscopy methods?
In the study that I presented, we didn't analyze microorganisms specifically. We analyzed the meats, and we after we analyzed the composition of the meats, the content of microorganisms that we can find in the meats, and we try to make the correlation between the spectra that we recorded on the same meats and the microbiological counts. So in the study that I presented you, we didn't analyze directly the microorganisms, but some of my colleagues, and also in the literature, some researchers have they made different plates, by selecting microorganisms, and they analyzed the colonies of a different type of microorganisms, and they identified that each microorganism's colony have a specific spectra, and based on those spectra, it was possible to differentiate between different category of microorganisms. I don't know if I answered to the question or not.
Yeah, I think you answered to the question. Also, I think we have someone who raised his hand, Robi. You can.
Yes, thank you, Bu Yayan. Hi, Abdurrahman, how are you?
I'm fine, thank you. How are you?
Okay, thank you for your presentation. It was
You're
excellent, and we are very happy. Yeah, we are very happy to see you again for the second time. I just want to ask about the future collaborations between Vet AgroSup and also Universitas Padjadjaran. Since the audience of this conference coming from different institutions, so I just want to know whether is it possible or not for our staff or students to join in the collaborations, because as you are presented, I think there are some similarities, yes, concerning the subject of the research. Yes, we also working on cheese, on milk. Yeah, some of our researchers also working on some new methodology. Yes, emerging methodologies to identify the properties of the food substance, for example. So I just want to know how to start our collaborations between Vet AgroSup and specifically with Universitas Padjadjaran. As we have already sent to you the draft of Memorandum of Understanding, I just want to know how is the progress of that document. Thank you, Abdurrahman.
You're welcome. So for the Memorandum of Understanding, I sent this document to the Dean, so I'm waiting his feedback. So concerning our collaborations, I have already some collaborations with Yana Kayana, Dr. Yana Kayana.
Yeah, Payana, yeah. I heard that.
And we have we succeeded in obtaining some finance concerning Science and Impact project. So I think it can be a good way to make collaborations, because with the money that we obtained, we can travel. You
Okay.
can come in France, and I can go to Indonesia, and we can
Okay.
also make some analysis, small analysis, but it can be a good way to begin. And
But
after
that's
we
for
have,
next year, yeah. Abdurrahman, that's for next year.
yes, for next year, yes, for next year. And we have also the PhD program,
Okay.
program, Naturama PAM. I don't understand the name, but the PhD can also be a good way. And we
Okay.
have also the possibilities to welcome, if you have scholarship, if your staff can have obtained scholarship from your university or your
Okay.
government, you can welcome them here. And we have also possibilities for the staff of my institution to have scholarship to go to your institution. So
Okay.
we can also share lectures, for example, virtual
Okay.
lectures between our two institutions can be a good way also to employ students, for example. We can do that.
Oh, that's great. Yeah. So I will talk further with you, yeah, and also with the other PIC of the agro-complex faculty, as we have done before, yeah.
Okay.
And do we have to wait until the MOU signed by your dean, or we just can run?
No, it's
without-
not necessary to wait. We can run, yes.
Okay. Okay, that's great. Okay, thank you, Abdurrahman. Thank you for
You're
sharing
welcome.
your knowledge with us.
You're welcome.
Thank you, Pak Robi, for your question. I think this is because our time is up, actually, Professor.
Okay.
So I would like to close this session, and I would like to give my valuable gratitude to you for your sharing knowledge, and also to the audience and to the committee. And also, I would like to give you the certificate of appreciation for today lecture. So
Thank you.
Certificate of appreciation. So
Thank you very much.
yeah. Lastly, I would like to give thanks to all of you for to have present in this lecture. So thank you so much, Professor, for your time. So I will give this session back to MC. Thank you.
Thank you.
Thank you. Thank you.
Yeah. Hello, MC. Do you have to close this? You might need to close this session today, or
Thank you very much, Professor Abdurrahman, for giving such an informative and comprehensive presentation.
Also, thank you, Dr. Yuan for being our wonderful moderator in the session.
Before we end this session, we would like to present Dr. Yuan with a certificate of appreciation for doing a great job today.
thank you.
And we would like to take a picture with you. And on my count, from 1, 2, 3.
Thank you.
Thank you.
Ladies and gentlemen, on behalf of the Second Virtual Mobility Program 2022, we would like to say thank you for your active participation today. Thank you to all the keynote speakers for their amazing presentation, and to moderator for being here to moderate today's event.
Now, before we close today's event, let us pray first. Pray based on individual religion beliefs begins. Over.
Thank you all the participants for attending today's event and for all the speakers and moderator. Have a wonderful evening.
My name is Nova Ramadan.
And I'm Nedelini Temawarae.
Your master of ceremony. Allow us to leave the main screen, and thank you for all for coming here.
Thank you.
Thank you.